It used to be science fiction, but now it's coming true. Submarines and credit cards are only two examples of how science fiction technologies might be applied in the real world. However, many believed that it would never be feasible to read minds. It turns out we were mistaken. Welcome to Z. Today, we're addressing the astounding query: did researchers just develop a brain implant that can read minds? The topic we're discussing today is truly the culmination of years' worth of effort across numerous fields. Parallel developments in the disciplines of neuroscience and artificial intelligence have accelerated the progress of research into mind reading. Progress has been made in comprehending and deciphering brain activity generally as a result of breakthroughs in both fields. But translating specific brain waves or firing neurons into something that can be read, into words and language, is the secret of mind reading. It's exciting to observe how recently it has become more and more plausible to translate ideas into language. Researchers described how they had been able to generate letters in real time using imagined hand motions in an article that appeared in the journal Nature in 2021. Simply asking people to visualize writing out words or letters allowed a computer to read their brain activity with up to 94% accuracy, allowing researchers to determine what the participants were imagining. The system makes use of a device known as a brain-computer interface, or BCI, which is a tiny chip or electrode that is implanted in or placed on the head to pick up neural connections and brain waves. However, there are currently other ways to gauge brain activity. A functional magnetic resonance imaging device, or fMRI, was utilized in research that was published in Nature in 2019. In the experiment, researchers were able to program an AI to replicate images of human faces that participants had previously viewed. By merely scanning the participants' brains and converting the recorded brain activity into another image, a variational autoencoder was able to recognize a person's face after presenting them with a produced image of that person's face. It was able to accomplish this 95% of the time. The specifics of yet another revolutionary experiment have just been made public. University of California, San Francisco researchers have succeeded in developing mind-reading technology even further than before. Back in 2019, working at neurosurgeon Edward Chang's lab, the team started researching a guy who had suffered complete paralysis as a result of a vehicle accident many years ago. After he consented to the procedure, doctors broke up his skull and affixed a tiny BCI to the surface of his brain to record his neural activity once more. After implanting the chip, researchers started looking into the man's potential communication methods because doing so had previously been impossible for him. It soon became apparent that he was now capable of mentally typing text onto a computer screen. Even though the research was somewhat constrained, it was nonetheless considered to be another breakthrough success. The individual could only correctly build phrases more than 25% of the time, and he could only speak from a list of roughly 50 words in total. But since then, the authors have written another study that once more features the same man. The team expanded its research in 2022 by changing their approach. They asked their participant to visualize letters using the NATO phonetic alphabet rather than words from a preloaded bank. He would concentrate on pronouncing alpha if he intended to pronounce A, Charlie for B, Bravo for C, and so on. With the help of this new method, he was able to create complete phrases and had a far larger vocabulary. More than 1,000 different words were decoded during the course of the investigation, far more than he could initially interact with. However, there are still some issues. His vocabulary may have grown as he spelled out each letter, but word construction was slower as a result. He moved from speaking 50 words to more than 1,000, and computer models suggested that he would be able to say up to 9,000 different words. He was only able to produce an average of 29 characters per minute, or roughly 7 to 10 words, at the same time. When compared to the speed of normal human speech, which is between 120 and 160 words per minute, that rate is incredibly sluggish. There is obviously still work to be done. The good news is that speed now seems to be the only thing standing in the way of scientists having true, in-depth talks with anyone's mind. We already have the foundational technology in place. All that is left to do is to improve and increase its effectiveness. In reality, we already do that to some extent. In a different experiment conducted in 2022 by the Caltech neuroscientist Sarah Wandelt, it was successfully shown that it is possible to decipher words rather than just letters by reading someone's thoughts. This time, an electrode was placed exactly on someone's posterior parietal cortex, a particular area of the brain, to conduct the experiment. Intriguingly, the participant in this case was bilingual, and it appeared that the connected computer could recognize both English and Spanish terms. The key drawback of this study was that it was still in its early stages and that the computer could only reliably identify words from a limited set of options. Indeed, there are many difficulties with this kind of research, which is one of the reasons it may have looked cumbersome in the past. There is a rumored lack of test subjects, and on those who do volunteer, experiments frequently necessitate invasive surgery that involves cutting through the skull and striking the surface of the brain. As a result of problems with maintenance, brain implants may eventually need to be replaced, which would necessitate another surgery and carry a risk. Non-invasive surface devices are also being developed, but so far they haven't been able to read the brain's thoughts with the same clarity. However, many contend that improving non-invasive implants is the safer course to take. There should then be far less risk involved, in theory. Finally, there can be some broader social repercussions to take into account. The ability of mind-reading implants to restore speech to those who have entirely lost their ability to speak has been demonstrated in all of the studies conducted thus far. Once only a pipe dream, we are now close to realizing this level of science and technology. Some others are worried about the many alternate ways it could go in. Could those who have implants also be significantly more vulnerable? For example, having access to someone's inner thoughts, could a mind-reading chip be utilized for more sinister ends? Could it be encrypted or hacked by a third party? Thankfully, for now, there are additional queries for a dystopian science fiction world. But researchers and developers will undoubtedly face a number of unexpected challenges. If mind reading becomes possible, the innate urge to think things out before speaking might vanish. And that might result in a very new planet. Whatever happens, there is still work to be done. Before implants are fully free-flowing, there is still much technological work to be done. We are aware that a brain transmits many more signals when it decides to speak than only the ones for the words it wants to pronounce. The signal for the word itself is mixed up with signals to move the tongue, mouth, jaw, and other parts of the body. In order to improve the efficiency of mind reading, we must learn to filter out the unimportant signals from the background noise. The computer systems used to translate brain activity are another crucial factor to keep in mind, since all implants to date require some sort of obvious midway point between one brain and another. Instant telepathy has not yet been demonstrated in an experiment, and the mechanics of this science fiction ability are still mostly a mystery. The next stage could come from efforts to make brain implants totally wireless, which would allow for greater practicability. As with any emerging technology, it's vital to keep an eye on the situation. The implants that we have today would have been quite challenging to imagine only a few decades ago. However, they are here, and everyone is waiting to see what happens next. Because that is how researchers are actually creating a brain implant that can read minds. How do you feel? Do you think we missed anything? Please share your thoughts in the comments, watch some more ZE videos, and subscribe to receive notifications of new posts.